Now we have seen that in order to execute any instruction, we have to perform many micro operations, and these micro operations have to be timed. In the sense, one micro operation has to be over, then only we have to start the next micro operation. For example, if you are starting an instruction, that is called instruction cycle, right? If you want to execute it, first you have to fetch it. In order to fetch it, you should know the address. So into the address register, we need to pass whatever is present in program counter, right? And after this, from the memory, we have to fetch the word which is given by the address register, and we have to fetch it into the instruction register, right? And after this, or during the same time, I can even say increment the program counter. Now if you see this operation and this operation, first this one has to be done, then only this can be done. You cannot perform them simultaneously. Similarly, first this one has to be done, then only this one has to be done, but these two can be performed simultaneously. So just to distinguish between or just to say when an operation should happen before what operation, in order to say that, we are supposed to recognize the clock times. See, we are going to have a system clock which is going to generate the clock signal, and that one will be given as input to all the devices. So all the devices are definitely going to see the clock pulses, but then they should distinguish one clock pulse from the next one, at least during the execution of an instruction. Once the instruction execution is over, for the next instruction they can again start from zero, but then while executing an instruction, all these operations have to be timed. For that we need the timing logic. So how to generate this timing logic is, watch it carefully. I hope that you remember a sequence counter. I am not going to draw this here, right? A sequence counter, it will have three inputs. So one is clear input, and the other one is increment, and then the other one is, see this, clock, which means this one is also going to operate on positive edges of the clock, which means, see, the symbol is positive edge triggered. So what I mean to say is, if you are having the clocks like this, clock signals like this, right? Now this one is a positive edge, positive edge, positive edge, positive edge, positive edge. So at those points, this particular sequence counter is going to increment the count. That is the meaning of it. Positive edge triggered means. Now assume that this is a 4-bit counter. Just for our whatever computer we are implementing, 4-bit counter is enough, right? So when we have this 4-bit counter, it means that we are going to have 4 bits here, right? With a 4-bit counter, it is going to count from 0 0 0 0 to 1 1 1 1, which means from 0 to 15 it is going to count. Got it? Then this one is going to be applied to a decoder. This decoder is nothing but 4/16 decoder. Generally decoder will have n inputs and 2 power n outputs, right? And at any point only one of them is going to be highlighted. So if you see this, it is going to have 0 to 15. So now we have these, we are going to name them as T0, T1, T2, so on T15. This is going to be useful, or it is going to be used as the timing device. So how is it going to be used is, see this, initially assume that we are having 0 0 0 in the sequence counter, right? So initially we will have T0 activated, okay? which means this signal will be 1 during the first clock, and whenever we see this particular positive edge, T0 will go to 0, because here see, after the first clock what happens is, from 0 this counter will go to 1, right? So whenever 1 is applied here, T1 will be highlighted, so which means T0 will go 0 for the next one, but then T1 will start here, from here to here. Got it? Therefore for some time T0 is on, and for some time T1 is on, which means for one clock, for the first clock T0 is on, and for the second clock T1 is on. Then after some time for the third clock T3 is on, right? And then for the next fourth clock T4 will be on, T4 will be on, and so on. Got it? So T0, T1, T2, T3, T4, and so on, it goes till T15, and again T0 will start. Now what is the advantage of having such a circuit is, because of this we can design the hardware in such a way that at T0 this particular operation will take place, right? And similarly at T1 this particular operation will take place, something like this. If you want this particular operation to take place at T0, then what we should do is, we should take this T0 and then apply it. So see this, so what should happen, when it is T0, PC should be selected, so that the contents of PC will be on the bus, and then load of AR should be selected. So we take AR address register, and to the load input we connect it. Got it? And if you remember the the selection bits for PC, I think PC is 0, 1, 0, right? Which means when S1 is 1, it will get selected. Therefore this T0 will also be applied to the bus. In the bus to S1 it will be applied, and S0 and S1 will be left out. Therefore by having this, what happens is, whenever it is T0, then we go and select the S1 onto the in the bus. Therefore PC will come onto the bus. At the same time that will enter AR address register. So using this, the contents of program counter will be loaded into AR. Got it? So every time whenever you start the instruction, you just clear this. You apply clear to this. When you apply clear to this, automatically the output produced will be T0, and automatically whatever the address is there in program counter, it will be loaded into the address register. Got it? And similarly you can do the next one. So whenever T1 is there, you can see that IR is getting loaded from M. So how to select this? Memory, if you have to select the memory contents onto the bus, you have to apply 111, which means this particular T1 has to be given to this, and along with OR gate it has to be given to this and then to this. We are generally having OR gates because various other instructions will also need it, various other timing signals will also need it. So anyway we see that whenever the clock signal is T1, S1 and S0 will definitely be 1 and S1 will be 0. Got it? S2 and S0 will be 1 and S1 will be 0. Sorry, all of them will be 1 because it is 1 1 1, right? So whenever T1 is 1, we see that S1, S0, S1 all are 1s. Then what will be selected on this one? This memory will be selected. Therefore the word which is present in this address will come onto the bus. So once it comes onto the bus, then we are going to load it to IR. So how can we do that? Now in the IR register, instruction register, we take this T1 itself and we apply to the load. So automatically it will be loaded. Got it? Therefore at T0 address is moved on to the address register, and at T1 instruction is moved into the instruction register. Got it? And at the same time you want PC to be incremented, right? That is why to the program counter also we are going to connect this. right? So that is how these control signals are generated by this circuit, which will be a part of the control unit, and these signals will be transmitted to the appropriate control inputs. Got it? So that is how automatically everything will happen by the hardware. Since we are implementing everything using the hardware, isn't it? This entire thing is a hardware logic. Since we are doing everything with the hardware, it is also called as hardware program control unit. Got it? And now the next one is what is this? This is one part of the, this is one part which is required in the control unit, and the other part is once you get the instruction, we have to decode it. For that we need the decoder. We shall see it now. Okay.
Hi, if you are planning to do masters, then doing masters abroad is better than doing masters in India. I'll give you all the reasons. So, first reason is, out of 1 lakh students who take GATE every year, there are only 500 seats in old IITs. So all the IITs put together have an acceptance rate of 0.5%, and IITs, universities better than IITs, they have very good acceptance rate like 30%, 40%, but all the IITs put together have an acceptance rate of 0.5%. And if you are working hard to get into IIT Bombay's ranking is 177 and IIT Roorkee's ranking is 400. If you are happy to get into IIT Roorkee, then getting into universities better than IIT Roorkee is easier compared to getting into IIT Roorkee. And looking at the salaries for computer science, for software jobs, if you have done your masters in computer science in US, the salaries are ranging from 80 lakhs per year to 1.2 crore per year. So even if you take an average of 1 crore per year, your savings will be much higher than the salaries in India. After taxes and your cost of living, you can easily save 40 to 50 lakhs per year. And in India, the maximum jobs that you get is around 30 lakhs. So your savings will be much greater than the salaries in India. And these are all the services that we provide. University shortlisting. So depending on your profile, we will shortlist what are the universities that you have to apply, and statement of purpose building, and then LOR guidance, and GRE and English test assistance, and education loan assistance. So you don't have to have any collateral, which means without any security, now you can get education loan. Getting education loan is very simple these days, and whatever the amount of fee that you have a range of universities. You can apply for 10 lakh universities, 20 lakh universities, or 50 lakh universities. But whatever it is, you are going to get complete education loan, and you can pay off your education loan in 1 year after you get a job. And then we do visa assistance, mock visa interviews, and then connecting with the university alumni. So now you might ask why we should join Game of Visas. So the answer is we have 90% success rate, 99% success rate. And these are all the destinations that we guide the students to. So we guide students to any country that you want to go. So now it is not just USA. We guide to UK, Germany, Australia, Canada. So we guide students to all the countries. We work with all the destinations. And if you are interested in going abroad, you have to just drop us a message on this WhatsApp number 9494 555 454. Okay, thank you.